folder, Windows Sheets. Yes. All right, let's get it started. So, here is our setup. We're given these traveling waves. We know the string, or the string is bouncing. It's 3 meters across from the wall that's unmoving to the, what you call it, pulley. And there's a weight on the pulley. Right? So we know that this weight is 2.5 kilograms. The energy in the standing wave is 40 millijoules, which is the same as 4 times 10 to the negative 2 joules. String, as we said, is 3 meters. This is our amplitude, and what we want is the amplitude of the standing wave. So, first, and then most importantly, we need to derive the equation for standing wave. So, let's do blue today. You know the energy of a traveling wave is given by 1 over 2 mu omega squared. Mu omega squared lambda amplitude squared. But now consider when you have a standing wave, the amplitude is combined, so this actually becomes a standing over 2, which is exactly what we want, right? So now what we get is 1 over 2 mu omega squared lambda 1 over 4 a amplitude of the standing wave squared, right? Yeah. So to get the energy of a standing wave, you just multiply this by 2. So all you do is just take off that 1/2, and what we're left with, energy of a standing wave is just, we'll put this constant up front, 1 over 4 mu omega squared lambda amplitude of the standing wave squared. So now let's save this over here. Actually, no, let's put it up top. That's gonna be more easy to reach. Energy standing wave is equal to 1/4 mu omega squared lambda a squared standing wave. Okay, well let's take stock of what we have now that we have our standing wave equation. So we know that this is just 1/4. Don't know what mu is. Don't know what omega is. We don't know what lambda is. We don't know what amplitude is either. All we know is the energy is 40 millijoules. So let's figure something out here. First, let's isolate the amplitude. So the amplitude of the standing wave is equal to the square root. Let's do the denominator first. It's mu omega squared lambda under 4 energy of the standing wave. All right, so let's attack this one by one. Let's figure out angular velocity. Angular velocity is 2 pi frequency. It's frequency. It's velocity over wavelength. And then what's velocity? Velocity is the square root of force over linear mass density, which works out because when we plug this back into force, we get square root of force over linear mass density times 1 over lambda, which we can put 2 pi in front of, and then since it's in the denominator, we also need to square it. What we end up with is omega squared is equal to 4 pi squared. This is this term, so that's force over integral mass density times 1 over lambda squared. That's our key here. So how does that cancel? Well, if we put it into, we're going to ignore square root for now. We can just do, we can start on the denominator, mu times this term here. That's 4 pi squared force. And then up top we have 4 is the energy of the standing wave times our denominators here, mu lambda squared, right? So, we're getting somewhere here. We can start canceling terms out. You see that here's a 4, here's a 4, there's a mu, and I forgot the lambda. Yeah, so there's a lambda in the denominator that I forgot to write, but these cancel anyways, so what we're left with is nice. The energy of the standing wave times the wavelength over, that's gone, force times pi squared. All right, we're getting somewhere. These are all very easy to find. So, what exactly are we talking about with force here? Well, force is just the tension here. So force equals to tension, and the tension is derived from mass times gravity, or in this case, gravity is our acceleration. So if our mass is 2.5 kilos, gravity is just 9.8 newtons. That gives us a force of, where's my calculator? Gives us a force of 24 and a half. Now let's put this over here. Force equals 24.5. All right. So, last term we have to figure out is our wavelength. So what do we do to get wavelength? Well, consider we know that the length of the string that creates the wavelength is given to us as 3 meters. We also know that the node, there's antinodes. There's 2 of them. So let's just use that in the equation. The wavelength is equal to 2 times the length over the number of antinodes, which is lambda equals 2 times 3 meters over 2. And that cancels, and we get lambda equals just 3 meters, right? Just save this in our bank over here. And at this point, we have pretty much everything that we might need to plug in for our amplitude. So let's do it. Amplitude, the standing wave, is equal to square root, we're going to make it nice and big, the energy of the standing wave. We're going to keep it in joules. So that's 4.0 times 10 to the negative 2 joules. The wavelength, which is calculated as 3 meters, all over force, which we calculated to be 24.5 times pi squared. That beautiful radical comes out to work over here. 4 times 10 to the power of 2 is 3 over 4.5 times squared we're left with is 0.022 meters, which we can just write as 2.2 centimeters.